Good afternoon, I am Mr. Ish. You are joining me for a useful video here, systems of linear equations. You know what that means. There cannot be an exam or a test out there, especially a standardized one, where you will not see at least one of these type of questions. So let's get right into it and let the first question be a sort of a compound question where we can discuss some of the important points of this. Describe the three forms of systems. And that right there is question number one. You know these are the three forms. You can have a representation such as this. You could have a line like this and another line, and the point of intersection shows you that there is only one solution. What is this one solution? Each of these lines has a certain intersection point. When they come together, that point represents your solution. But what is the characteristic of these two lines? For each of these lines, their slopes, right? Their individual slopes of each line are different. Hence, you're having this formation over here where you have a single solution for two lines. That's one form of a question that can show up. Another form of a system or a question is this. You happen to have one line, and then you happen to have another line which is directly parallel to it. Now in this instance, since there is no union or intersection of these lines, you have no solutions for this system over here because there's no contact made between the lines. Another good point about this is what the slopes of each of these lines are equal, right? The slopes of each line are same, hence they're parallel lines. And another point is they have different y-intercepts. Think about it. Each of these has a different y-intercept, but they have the same slope. And that's a good characteristic of this presentation here. The last presentation that you can see is one of this form where you have two lines, but they end up being coincident lines, which means you have one line upon which another line happens to land. So you have two coincident lines. Example of that representation could be such as this: x plus y equals 2, and how about 2x plus 2y equals 4. If you were to divide the second line by 2, it would actually be the same line. So these are lines which seemingly look different, but they're exactly the same. Hence, you have a line on top of a line. In this instance, you have infinite number of solutions because all the points which fall on one line happen to fall on the other line because it is the same line. That's what you have, infinite solutions. Another point is, of course, the slopes are the same because it is the same line. Slopes are same, and we will lastly identify this last point. I'll put it here. The y-intercepts are the same. The reason why the y-intercepts are the same is because they're actually the same identical line. So keep this in mind. The three representations of systems of linear equations. The second question of this video takes us to our conclusion of the video, and we have to solve this system. And basically we're talking about two lines for which you have to determine a point of intersection. You have multiple methods for doing this. You can use the substitution method, the elimination method, or you can even use a matrix algebra technique. Use the situation or the type of technique which for you is the most easy. And there is nothing wrong with you doing the elimination method for over here. Find a variable that can easily cancel out and then solve for the other variable. If I multiply everything in the top equation by 2, I'll get a minus 2x plus 4y is equal to 6. The lower one line where stayed the same, right? I'll add these because by adding them, I'll cancel this out. I'll have a 5y is equal to a 5 and y is equal to 1. Once I've determined y equals 1, you can plug it in any of these original equations, and why not, I'll just plug it right over here. I have 2x plus 1 is equal to minus 1. I took this y value and I plugged it right in here. 2x is equal to minus 2 and x is equal to minus 1. So how do you represent your solution for this system? You write minus 1 comma 1. But that right there is not your final solution. You actually have to test these out to make sure your answer is indeed true. You put minus 1 in places of x and you put 1 in place of y. If I put minus 1 here, I get a 1. 1 plus 2 is equal to 3, so it checks out for the first equation. It works. Then I do the same right here. I have a 2 times minus 1 is a minus 2. Minus 2 plus 1 is a minus 1, so it works out. So this equation is good. What does this tell you? It was two different lines, intersecting lines. They each had different slopes. They had different y-intercepts, and they have one point of intersection. Therefore, there's one solution. You can even look very quickly over here at the first equation, minus x plus 2y is equal to 3. Convert it into the y equals mx plus b format. 2y is equal to x plus 3, and y is equal to x over 2 plus 3 over 2. The first equation here has a slope of 1 over 2. Look at the second equation. Take the 2x on the other side. Y is equal to minus 2x minus 1. Right here, the second equation has a slope of minus 2. So they both have different slopes. And again, we are confirming what I said. Different slopes, different y-intercepts, two different lines, and hence one single point of intersection and one solution to this system. And with that, we end this video. Thank you for watching. Stay tuned. Have a nice day.